So today we will work on solving rational inequalities. So here's what you can do if you want to solve a rational inequalities. So the first thing is I suggest that you do a graph. So you sketch your equation or inequality, sorry. So if you want to sketch, so first you should sketch. Now if you want to sketch, you need the right form. Right now it's not in the right form, because remember the right form is a over x minus h plus k, and you realize here your x is positive, so we're going to change it into the right form. So right now you have 6 over 4 minus x. I'm just going to switch this like this, smaller or equal to 5. And what you need to do is your negative, you need to factor your negative. So you're going to have 6 over negative x minus 4, smaller or equal to 5. And then what happened is that here you have 6 divided by negative 1. So that's going to give you negative 6 over x minus 4, smaller or equal to 5. So if, sorry, not 4, 5. So if you want to sketch this, you're going to need to put your asymptote at 4, and then your k here is like 0. Okay, so you're going to have to go at 4, your asymptote here, and then 0. And because your a is negative, you're going to have to sketch something like this. And you want to know when this is going to be smaller or equal to 5. So 5 is going to be somewhere here. So you want to know when it's smaller or equal to 5. So you want to find this part and also this part. All right. So the second thing you can do after you're done sketching and finding the right form is you want to solve to find out that point. Okay, so you want to find out that point over here. So what you have to do, number 2, is you can make it equal and solve. So you're going to write 6 over 4 minus x is equal to 5. Now, how do you solve this? 5 is over 1, so you can times this equals this times this. So it's going to give you 5 times 4 minus x is equal to 6 times 1. So you have 20 minus 5x is equal to 6. And then you can move your 20 on the other side. So minus 5x is equal to 6 minus 20. So you have x is equal to 14 over 5. I know some of you like the decimal, so that is equal to 2.8. So now that we have our point, we know that x here is 2.8. Does it make sense? Our asymptote was at 4, so yes, it makes sense that it's 2.8. Now, how would you write your answer? Remember that you have to start from left to right. So if we're describing the red curve, I can write it in red. We're describing the red curve here. Okay, so we're going from minus infinity to 2.8. And is that included or not? If you go back to your original question, it was smaller than or equal to. So yes, it has to be included. Union, if I describe this curve here in red, I start at 4, but 4 is not included because it's my asymptote. And then I go up to plus infinity. So that's one way of doing it using the graph, and I think that's the one you should be doing because that's the one that's easier, and also it makes you practice your graph. But I know that some of you will like to do it algebraically. And what happened when we do it algebraically is that remember when you multiply or divide by a negative, you need to switch your sign. So let's do it algebraically, but then you have to remember we're going to have 2 options. So let's do it on the next slide so we have more room. Okay, so let's start with this. But this time we're going to do it algebraically. So if I start with this and I want to multiply, to get rid of this here at the bottom, I want to multiply on both sides, then that 4 minus x can be two things. It can be positive or it can be negative. So if 4 minus x is positive, remember it cannot be equal to 0, right? Because we can never divide by a 0. So if my bottom is positive, then this signs will remain the same, right? So I can write 6 smaller or equal than 5, 4 minus x, and then I'm going to solve for that. And the other option is that my 4 minus x is negative, and therefore I'm going to need to switch my sign, and that's going to give me a second answer. All right, so if I'm going to start, I should put that like here. So I'm going to start on the left side. If I'm on the left side, that means minus x is greater than negative 4. I need to switch to positive x. So I'm going to switch x is smaller than 4. So that's my first condition. And then I can solve for that. So 6 smaller or equal 20 minus 5x. I can switch my 5x here. I can bring it on the left. So I'm going to have 5x smaller or equal to, and then my 6 I bring on the other side. So this one I'm going to bring it here. This one I'm going to bring here. So this x is smaller or equal to 14 over 5. So I have this, and also I have this condition, right? So remember, if we use a number line, if I use a number line, I have 14 over 5, and I have 4. X is smaller or equal to this. X is smaller than 4. So which one includes both conditions? It would be this. So my x is smaller or equal than 14 over 5. So that would be the answer on the left side. Let's look at the right side. So I'm going to keep doing my top part here. So x has to be greater than 4. So that's my first condition. And then I solve down here. So I'm going to have this 20 minus 5x. And I'm going to do the same thing. So bring my 5x over 14. And x is greater or equal to 14.5. But when I look at both conditions, and I can use my number line again to show. So if that's 14 over 5 and that's 4, x is greater than 4 and x is greater or equal to 14 over 5. Which one includes both conditions? Is this one. X is greater than 4. So when I write down my answer, I need to combine these two. It's going to come up here. So my answer would be x is smaller than 14 over 5, so minus infinity to 14 over 5 included, union 4 excluded to plus infinity. So you realize that we end up with the same answer as before. It's just that we did it algebraically. So you can always use both methods to check that you're doing it right. Have fun!